So welcome students, welcome to all of you in this video lectures. Here I am going to continue the chapter 2. The name of the chapter is Relation and Function. In this video lectures I am going to explain the concept of function. So students, in the last video lectures I have discussed about the relation, and in this lectures I am going to explain the concept of function. So what is a function? A function f from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. So student, there is a similarity with the relation. Relation R is also a subset of A cross B, and here function f is also a subset of A cross B. That means the function is nothing but a set where the elements are the pair of elements, and those elements belongs to the elements of A cross B. Okay students, so f is a subset of A cross B, but there is a condition for the function. The condition is every element of set A has one and only one image in the set B. That means the element of the set A should not be repeated. Every element of set A must have their unique image. So students, in other words, a function f is a relation. Function is nothing but a relation. A function f is a relation from a non-empty set A to a non-empty set B, such that domain of f is A, and no two distinct ordered pair in f have the same first element. So students, here the last line I am repeating again. Every element in the domain must have their unique image. Here is some example given. If f is a function from A to B and AB belongs to f, AB is an element belongs to f, then we can express this element like f of A equal to B, where B is called the image of A under f, and A is called the pre-image of B under f. So students, in this particular element, B is the image of A and A is the pre-image of B under f. So here one example is given. A function f from A to B is denoted by f is a function such that A to B, and where capital A is an element taken small a, b, c, d, e, and capital B is an element capital A, capital B, capital C, capital D. Now since f is a function from A to B, so f must be a subset of A cross B. So here are some elements taken. F, which is an element, the elements which is a subset of A cross B, the elements of f are taken small a, capital A, small b, capital B, small c, capital C, small d, capital D, small e, capital A. So students, you can see that the first element of each ordered pair of the set F, which is A, B, C, D, E, which are unique, and these elements are not repeated. The elements of the set A, B, C, D, E are not repeated here. So it is concluded that f is a function. Okay students, the image may be repeated, may not be, but the elements of the domain must have their unique image. So we can express each and every element like this. Capital A equal to f of A, capital B equal to f of B, capital C equal to f of C, capital D equal to f of D, and capital A equal to f of E. So I hope students, you understood the concept of function. So in a function, the elements of function, the must have the domain of the elements of function must have their unique image, and F must be a subset of Cartesian product of two set. So students, I hope all of you understood this concept. Next, I'm going to discuss some more concept of function. So in function F, we have in this function set, we have taken the elements. The pair of elements are these elements we have taken, and in this function we have domain of F equal to the first element A, B, C, D, E, and the images of A, B, C, D, E are capital A, capital B, capital C, capital D, capital A, E. So you can say that the image of small a is capital A. The image of small a is capital A. The image of small b is capital B. The image of small c is capital C. And similarly, the image of small e is capital A. So students, it is very important that the images of every element of domain must be unique. And the images can be expressed with the help of domain like this. Students, there are some more functions are taken. F1, the elements of F1 are small a capital A, small b capital A, small c capital C, small d capital D, small e capital D. So here you can see that the domain is not repeated. The domains are A, B, C, D, E, small a, B, C, D, E. So since the domains are not repeated, so you can say that F1 is a function. Okay, students? And here the D is the image of, capital D is the image of small d and small e. Okay, students? This is no problem. Image may be repeated, but domain must be unique. In F2, the elements are small a capital B, small b capital B, small c capital C, small d capital C, small e capital D. You can see that the domains are also unique, A, B, C, D, E. So it is a function. F3 also the domains are A, B, C, D, E. It is also a function. In F4 also the domains are unique. So these all are F1, F2, F3, F4 are the examples of functions. And one more example is taken, which is relation, but which is not a function. So students, you can identify that why R1 is not a function. In R1, you can see that the elements are taken small a capital A, small b capital B, small c capital C, small d capital D, small e capital A. So students, you can see that the domain A is repeated. A is having two images. One is capital A and another is capital B. Okay, students? So this is not the condition of function. The condition of function is every domain must have their unique image, one image, but here we can see that the images are repeated. So it is not a function, but it is a relation. So R1 is not a function because images of A is repeated. One is capital A, another is capital B. So hence R1 is relation from A to B, but not a function. Hence we can conclude that every function is a relation, but every relation may not be a function. I hope students you understood the concept of function and relation. And now I'll discuss the concept of function using arrow diagram. You can see that how many total number of functions is possible from A to B. in a particular set. Here set A is taken 1, 2 and B is taken 5, 6, 7. So students, the elements in A, number of elements in A are 2 and number of elements in B are 3. So the total number of functions is possible is 3 square. Number of elements are B are 3 and number of elements in A are 2. So if you do 3 square, we will get the number of possible functions from A to B. Okay students, and there are some diagram given. The first function is possible 1, 5, 2, 5. Here the domain is both the domain 1 and 2 having the same images 5, but the images of domain are not repeated. Images may be repeated but domain should not be repeated. There is a condition of function, so it is a function. Here the image of 1 is 6 and the image of 2 is 5. Here also domain is not repeated, so it is a function. This one is another function. So there are total 9 possible functions can be produced from the set A cross B. The students, number of functions from A to B is nothing but 3 square, which is 9. So these are the 9 functions which are expressed in the form of arrow diagram are listed here in this diagram. So I hope students understood how to find the number of functions from a set A to a set B from any Cartesian product of two set. The students, there are here I will discuss some types of functions. The first type of function is identity function. In this type of functions, we can express like this: y equal to fx equal to x. Here y and x are equal. So this is identity function. Next is constant function. Here the value of fx is a constant, y is a constant. So y equal to fx equal to c. And this is the diagram of constant function. Next is polynomial function. As you know, the polynomial function is quadratic function, cubic function, like this. Rational function. Rational function is fx by gx. Is a quotient, is the quotient of two functions. The modulus function is fx is mod x. The fx is mod x having two values. One is x when x is greater than or equal to 0, and other is minus x when x is less than 0. And this is the diagram of modulus function. Signum function having three values. One is 1 when x is greater than 0, one is 0 when x is equal to 0, and one is minus 1 when x is less than 0. And this is the diagram of signum function. Next is greatest integer function. We can say it is a box function. Fx equal to box x belongs to R. Here if we take box 1.3, so we have to consider 1. If the box 1.9, then its value is 1, because here we are considering the highest integer function. In 1.3 the highest integer is 1. 1.3 lies between 1 and 2. So since it is less than 2, so we have to pick the highest integer from this value 1.3, and it is nothing but 1. Similarly, the other values are also given. Since there are some algebra of real functions, this is the addition of two functions. You can add two functions, f plus g into x. You can write fx plus gx. Subtraction of real function, f minus g into x equal to fx minus gx. Multiplication of a scalar, alpha into f, x equal to alpha fx. And multiplication of two real functions also can be done. F into g equal to fx into gx, and quotient of two real functions, f by gx equal to fx by gx, provided the function gx should not be equal to 0. for small x belongs to capital X for any particular value of x which lies in capital X. So students, I hope all of you understood the concept of function, the types, and how to find the number of functions from a particular Cartesian product of two set. So students, here I am discussing some questions. The first question is, which of the following relations are functions? Give example. If it is a function, determine its domain and range. The first question is, the first set is given 2, 1. The elements are 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. So you can see that the first element, the domain, is not repeated numbers. All are unique numbers. Okay students, so if domain is not repeated, then we can say that it is a function. Since it is images are repeated, the image of 2 is 1, image of 5 is 1, image of 8 is 1, image of 11 is 1, image of 14 is 1, and image of 17 is 1. Images of all the domains is 1, but the domain is not repeated. The same domain should not have more than one image. So students, you can say that this is a function. Next one, you can see that the first element, the domain, are 2, 4, 6, 8, 10, 12, 14. All are unique, not repeated. So it is also a function. Next one, 1, 1, 2. You can see that 1 is repeated here. The images of 1 are 3 and 5. So this is not the condition of function, because in function the domain must have unique image. But here you can see that the domain 1, the image of domain 1 is not unique. There are two images of 1. One is 3, another is 5. So this is not a function, but it is a relation. So I hope students, you understood this question. Next question is very important. Find the domain and range of the following real functions. The function is f(x) equal to minus of mod of x. So we know that the modulus function is x when x is greater than or equal to 0 minus x when x is less than 0. So when you multiply this function by minus of x, minus of mod x, it implies minus of mod x equal to minus of x when x is greater than or equal to 0, and this minus will multiply with that minus, it become plus, this minus become plus, so it is x, condition is x less than 0. So students, this is the condition of real number, because x is greater than or equal to 0, x is less than 0. So since x is the domain, so you can say that domain is nothing but real number, x is belongs to R, so domain of f is R. Now we have to find the value of fx, which is nothing but the range. So since students, you see that here when x is positive, its value is negative. So it gives a negative value. And here when x is positive, but it is valid for when x is less than 0, when x is negative. So it gives also negative value. So the range of f is always negative up to 0, because here 0 also. So you can see that minus infinity, range of f is minus infinity to 0. I hope students understood how to find the range of a function. Its answer is minus infinity to 0. So why it is closed bracket? Because when you put the value of x is 0, the value of fx, which is the range of the function, is also becomes 0. So you concluded that the range of f is minus infinity comma 0. The next question is, find the range of each of the following function. One function is given, we have to find the range of this function. The question is fx equal to 2 minus 3x, x belongs to R, and x is greater than 0. So students, since x is the domain and fx is the range. So and the value of x is given greater than 0. So students, from this function, let us consider the value of fx is y is also range. So when y equal to 2 minus 3x, so you can express this function in the form of x equal to 2 minus y by 3. After side change and cross multiply, you can find x equal to 2 minus y by 3, and since x is given greater than 0, so this function is also greater than 0. 2 minus y by 3 is greater than 0. After cross multiplication, 2 minus y is greater than 0. So here 2 greater than y or y less than 2. So from this we can write down the range of f, because y is strictly less than 2. The range will be minus infinity to open bracket 2. So I hope students, all of you understood the concept of function and its related questions. Here are some questions I am giving to all of you. All of you try yourself, and if you have any doubts, you can contact me. Thank you very much.